All right, so we just discussed several properties of exponents, but one thing we didn't cover, if you notice, all the exponents we had in here were integers. In other words, they were positive or negative, but they were whole numbers. So what I want to talk about is what happens if we have a rational exponent, or in other words, a fraction in our exponent. And to understand what that means, we're going to go over sort of what kind of situation would we use these exponents in. So for the sake of this exercise, let's assume we're only going to deal with positive numbers. So we'll deal with x's that are greater than or equal to 0. So something you probably are familiar with is if I have an equation like x squared equals 25, what would I do to solve that? And your inclination is probably to take the square root of both sides, which would be absolutely correct. And of course, assuming that x is greater than or equal to 0, then x would be the square root of 25, which is 5, right? So I can cancel out that squared by doing the square root, and I just get x. But consider another possibility. If I have that same problem, x squared equals 25, and I'm solving for x, using our properties of exponents, notice when we have raise a power to a power, those exponents are multiplied. So if I want to go from x squared down to just x, or in other words, x to the first, another way to get rid of that squared while still using exponents is to say, well, what can I multiply the 2 by to get to 1? So hopefully you remember any number multiplied by its reciprocal. So this is like 2 over 1. So I raise it to the power of 1 over 2. Of course, same thing on the other side. And a power raised to a power, I multiply 2 times 1/2 is just 1. And then, of course, if I put in the calculator 25 to the 1/2, I get this same thing, x equals 5. And so what we basically just showed is that when I do a square root, or when I do a 1/2 power, those two are equivalent. So similarly, if I have x cubed equals, let's say, 27, then just like we could take a square root to get rid of x squared, or get rid of the squared, I can take what we call a cube root to get rid of the cubed. It's the exact opposite, the inverse operation. So I would take the cube root of both sides, so I get x is the cube root of 27, which hopefully we know what number cubed is 27. 3 times 3 times 3 is 27, so x equals 3. Again, similarly, if I had x cubed equals 27, the other way I could solve that is to say I want to make this x to the first, so 1 is 3 times 1/3, right? The reciprocal, 3 over 1, 1 over 3, it cancels out. So I do 27 to the 1/3, so I get x equals 27 to the 1/3, which would give me the same answer, 3. So that cube root is the same as a 1/3 power. So, final example, if I asked you then, what is 16 to the 1/4? Well, whenever you see 1 over a number, notice that means it was that root. So 16 to the 1/4 would be the 4th root of 16, or in other words, what number raised to the 4th equals 16? And hopefully we know that's 2 because 2 to the 4th equals 16. So, long story short, in general, if we have x to the 1 over n, what that means is the nth root of x. All right, so let's add one more twist to that. Instead of, notice these, we know what the 1/2 or the 1/3 or the 1/4 means now. What if I had, for example, 9 to the 3/2? What would I do? And so what I'm going to do is use this same property, but this time I'm going to use it backwards. And I say if I have 9 to the 3/2, well, I know what 9 to the 1/2 is. So I can say this is 9 to the 1/2 raised to the 3rd, and the reason I can say that, of course, is that when I multiply those, 1/2 times 3, right, would be 3/2. So these are equivalent, but this makes it easier for me because 9 to the 1/2, same thing we were saying up here is, or over here, the 1/2 power is the same as a square root. So that's the square root of 9, and then that whole thing was raised to the 3rd. But of course I know the square root of 9 is 3, so this is 3 to the 3rd, which is 27. All right, one more example. Let's say we have 8 to the negative 2/3. So a couple things to deal with. It doesn't really matter which order I deal with them. Let's get rid of that negative first. Remember, when we have a negative power, that means that I can make that power positive by putting it on the denominator of the fraction. So 8 to the negative 2/3 would be 1 over 8 to the positive 2/3. But I still need to break that down, so that would be 1 over, and let's do the same thing we did up here. That would be 8 to the 1/3, and then raised to the second power, or in other words squared, because the 1/3 times 2 would give me 2/3. But what is 8 to the 1/3? Well, remember the 1/3, or the 1/nth power is the nth root, so the 1/3 power is the cube root, or the third root of 8. And then, of course, that whole thing was squared. So what's the cube root of 8? Well, what number to the third power equals 8? That would be 2, so that's 1 over 2 squared, or 1/4.